Okay, let's unpack this. I want you to close your eyes for a second. Well, unless you're driving, in which case, please keep them open.
Good point.
But imagine you are back in school, it's a Tuesday morning, the lights are humming, and you're staring at a piece of paper.
A multiple choice test.
A multiple choice test. You're on question 4. You look at option A, no. Option B, maybe. Option C, that's definitely a trap.
Oh, absolutely. The classic process of elimination, the sweat on the palms, that feeling that C has been the answer 3 times in a row, so it can't be C again.
Exactly. We've all been there. It's this, universal experience. But today, I want to flip the camera around. Let's think about the person writing that test.
The teacher.
The teacher, late at night, trying to come up with 30 questions. And not just questions. You need 1 right answer and 3 plausible fake ones for every single one.
Which is, I would argue, much worse than taking the test. There's a reason teachers dread exam season too.
It sounds miserable. And according to the research we're looking at today, it is a nightmare. The paper calls it time-consuming, labor-intensive, and just a guessing game.
A huge creative burden.
Right. But what if you could automate it?
And we're not just talking about a computer, randomly grabbing sentences and deleting a word. We're talking about a system that learns how to ask questions.
Today we are diving deep into a fascinating paper called Bootstrapping Multiple Choice Tests with the Mentor. It's from a team in Lisbon, Portugal Anasan, Cristina Mendes, Sergio Curto, and Luisa Coher.
And their mission really was to build a computer system that reads the internet to teach itself how to be a teacher.
A system they call the Mentor. And the key word here, the thing that makes it all work, is bootstrapping.
Right, bootstrapping.
I love this term. It sounds like, pulling on boots or starting a business with nothing.
And in computer science, it's not that different. It's the answer to the classic chicken and egg problem. Well, usually to teach a computer something complex, like writing a quiz, you need tons of training data, thousands of examples of good questions.
But where do you get the questions if the system doesn't exist yet to make them?
You're stuck, exactly. So bootstrapping is about starting with a tiny seed, a really small amount of information.
Just a little nudge.
You give it a nudge, and it uses that to find a little more data, and then uses that data to find even more. It basically runs a marathon after you give it a push.
So let's break down how the Mentor does this. The paper splits it into 2 phases. The offline phase, which is where it learns, and then the online phase, where it actually makes the test.
Let's start with offline. This is where it learns the patterns of language, and it all starts with that seed.
The researchers give this great example. They feed the system 1 single fact, a question and an answer.
Yep, question. Who painted the birth of Venus? Answer, Botticelli.
Simple enough. A human gets that relationship. Artist, painting. But the computer?
The computer has no context. It doesn't know what painted means. It just sees strings of text. Symbols.
So how does it get from that one specific fact to a general rule?
It starts by mixing things up. It takes the key parts, Botticelli, Birth of Venus, and rearranges them. But it adds a special ingredient, the wild card.
A wild card. Is that like a blank tile in Scrabble?
That is a perfect analogy. It's a placeholder, so it generates search strings like Botticelli wildcard, painted the birth of Venus.
Ah, so it's looking for the words that usually connect those ideas in human speech.
It's looking for the glue. And then, and this is the very modern part, it just Googles it.
It literally Googles it.
Literally. It takes those strings, puts them in double quotes for an exact match, and pings a search engine. The whole idea relies on the redundancy of the web.
Redundancy is usually a bad thing, but here it's the fuel.
It's everything. The internet is so massive that if a sentence structure is grammatically sound, chances are somebody, somewhere, has written it.
So maybe it finds a hit.
Right. It finds a sentence. Botticelli has painted the birth of Venus.
So the wild card was the word has.
And from that one hit, it extracts a pattern. It learns that answer has VBD NP, which is just code for answer has verb noun phrase, is a valid structure. It's not learning from a grammar textbook.
It's learning grammar from seeing it in the wild. That's the aha moment for me. It's observing how humans actually talk, not how they're supposed to.
Which is both a strength and a huge weakness.
Well, yeah, I can see the weakness coming. The internet is messy.
To put it mildly.
Just because you find a pattern on Google doesn't mean it's a good pattern for a test. The paper talks about patterns being too specific, right?
It's a huge problem. Let's stick with Botticelli. Suppose the system finds a sentence on a history blog that says, the birth of Venus was painted around 1486 by Botticelli.
I mean, that's a perfectly factual sentence.
It's factual, sure, but look at the pattern it would extract. NP was painted around 1486 by Answer.
Oh, no.
If the system thinks that's a general rule about art, you're in trouble.
Because if you try to ask, who painted the Mona Lisa, you get.
The Mona Lisa was painted around 1486 by Leonardo da Vinci, which is just wrong. The date 1486 got baked into the pattern.
Right.
It over-memorized.
So how does it stop itself from learning these bad habits? You can't have a human checking every single pattern.
This is the brilliant part. It uses validation pairs. Think of it as a sanity check.
Okay, how does that work?
Every time you give it a seed-like Botticelli Birth of Venus, you also give it a validation pair. Let's say Picasso and his painting Guernica.
Okay, so two separate true facts.
The system takes that suspicious patterns, the one with 1486 in it, and tries to jam the validation pair into it.
So it constructs a search for Guernica was painted around 1486 by Picasso
And it Googles that.
and gets 0 results.
Yeah.
Because that never happened.
And that 0 is the signal. The system sees 0 hits and thinks, oops, this pattern doesn't generalize, and it throws the pattern away. It self-corrects.
That's incredibly smart. It's like using a second fact to cross-examine the first one.
It is, but the researchers point out you can't just pick any random validation pair. They have to match syntactically.
You mean you can't check an artist question with a geography answer?
Exactly. If your seed is, who is the president of France? The answer is a person. You can't validate that with, what is the capital of France? Where the answer is a place.
Apples to apples.
Precisely. And make sure the categories align before it even tries.
So we have this machine running, scraping Google, building a library of how to ask questions. The paper actually puts these into 3 categories.
Right. And this is where you see that classic trade-off between quality and quantity. Precision versus recall.
Okay, what's the first type?
The first are strong pattern.
The gold standard.
They're the safest. A strong pattern has to contain all the key phrases from the original question. If the seed used the word painted, the pattern has to use painted.
So very accurate, but I'm guessing pretty restrictive.
Very. You don't get a ton of questions that way.
What?
Which leads to the second type, inflected patterns.
Okay, inflected is a grammar term. What does that mean here?
It's about the shape of words, specifically verbs. The system is smart enough to know that paint, painting, and painted are all related.
So it doesn't need an exact word-for-word match.
Nope. It can see a sentence like, Botticelli has finished painting, and it knows that still answers the question, who painted?
That feels like a big jump in intelligence. It's reading the intent, not just the letters.
It makes the system much more flexible. But then you have the third category,
The weak patterns.
the troublemakers.
The name gives it away.
A weak pattern is a really loose match. It usually happens when the verb gets dropped entirely, like a sentence that just says, The Birth of Venus by Botticelli.
There's no verb, no painted, no created, just a comma and by.
Right. It's a weak connection. And these generate the most patterns by far, but they also produce the lowest quality questions. It's quantity over quality.
So you get a lot of noise.
A lot of noise.
Okay, so we've built our library of patterns from strong to weak. Now we get to the online phase. We actually want to make a test. And in the experiment, they used a specific text.
They did. They used the Wikipedia article on the history of Portugal.
Which is a great choice. Dense, factual, lots of names and dates.
So the system scans this text. It isn't reading for meaning, it's just scanning for sentences that fit the blueprints it learned earlier.
But I'm worried here. Just because a sentence fits a pattern doesn't mean it makes a good question. Like, he is a writer. Who is he? Is a terrible question.
You've hit on the 2 big filtering problems. The first is that vague language, what they call anaphora. The system is designed to throw out questions that rely on pronouns like he, she, or it.
So it avoids those meaningless questions.
Right. But the second filter is even cooler. It uses something called WordNet.
I've heard of WordNet. It's like a thesaurus for computers, right?
Sort of. It's more like a family tree for words. It understands hierarchies. It knows a writer is a type of person.
How does the mentor use that?
Well, say the system generates a question starting with who. That implies the answer must be a person. But what if the answer it pulled from the text was 1995?
Yeah. Who is 1995? Makes no sense.
But how does the computer know? It asks WordNet, is 1995 a person? WordNet says no, it's a time. And the system kills the question.
So it's fact-checking the logic of the language itself.
It's enforcing semantic sense. It stops you from asking, who is the capital of Portugal?
Okay, so we have a valid question and a correct answer. Now for the hard part. The distractors. The wrong answers.
The art of the distractor, this is surprisingly tricky. If the answer is Lisbon, you can't offer table and chair as the other option.
Right, because I could just eliminate the absurd ones. The fakes have to be plausible.
They need to be in the same category. Other cities.
So how does it find those plausible fakes without a human?
It goes back to the source text, that History of Portugal article. It looks for other proper nouns name entities that match the category of the right answer.
So if the answer is a person, it finds other people in the text.
Yes, but with two key rules. First, the category has to match. Second, it pulls them from nearby sentences.
Why nearby?
Context. If you're asking about the 15th century, you want the distractors to be other people from the 15th century. Pulling from nearby texts makes it much more likely they'll be thematically relevant.
That is really clever. But what about pulling from the same sentence? That can be confusing.
It's programmed to avoid that. It never pulls from the sentence the question came from. It looks at the neighborhood, but not inside the same house.
So that the big question,
Yeah.
they ran this experiment on the History of Portugal article. Did it work?
It did, but with some really interesting caveats. They processed over 800 sentences. The strong patterns, the safe ones, produced 59 questions.
59. Out of 800 sentences, that seems like a pretty low yield.
It is, but the quality was incredibly high. The researchers said most of them needed only minor revisions or none at all.
And the weak patterns. The loosey-goosey ones.
They generated the most raw material 110 questions, but, and this is the big catch, most of them had to be thrown out or needed major rewrites.
So they created more work for the human editor.
Exactly. And that's the key takeaway. This is a computer-aided system, not an automatic one. It's meant to create a first draft. It kills the blank page problem.
It turns the teacher into an editor, not a writer from scratch.
Precisely.
They mentioned some funny failures, though. My favorite was about the King of Spain.
Oh, yes. The system generated the question, who became Philip I?
Who became Philip I?
And the answer it pulled from the text was the Spanish king.
So the question is asking, who transformed into Philip I?
Right. It's grammatically okay, but it's logically backwards. A human immediately knows to rephrase that to, what did Philip I become? Or, who was Philip I?
It shows the system gets syntax sentence structure, but it doesn't get meaning.
It knows the math of the language, but not the soul of the history.
That's a good way to put it. So
Oh.
zooming out, we went from one fact about Botticelli to a Google search to a pattern and ended up with a quiz on Portuguese history.
It's an incredible demonstration of using the web not just as a library, but as a model for language. The system bootstrapped its own education.
And for a teacher, instead of staring at a blank page, you get a checklist. Here are 50 potential questions. Pick the good ones.
It shifts the work from creation to curation, which is a massive time saver.
But I want to circle back to something. This whole system relies on the redundancy of the web. It needs millions of human-written sentences to learn what sounds natural.
That's the fuel for the whole engine.
So here's a thought to end on.
Yeah.
We're moving into a world where more and more of the web is written by AI. If the web gets flooded with machine-generated text, does this loop break?
That is a profound question. This system learns from natural human phrasing. If the web becomes an echo chamber of AI repeating AI, we could lose that variation. The bootstrapping might start pulling up errors or just weird AI speak.
The snake eating its own tail.
Exactly. If the web is the teacher, we need to make sure the teacher is still human. Otherwise, the system is just validating its own hallucinations.
Something to think about the next time you're taking a quiz. Look at the distractors. Did a human write that, or was it a bot searching for patterns in the cloud?
And if one of the options is chair, you probably know the answer.
Thanks for listening to this deep dive. We'll see you next time.